Hello everyone and welcome to my YouTube channel NN Fabien Chemistry. So today we shall be learning how to calculate the concentration of solutions. Now if you've not yet subscribed to my YouTube channel, make sure you subscribe and turn on the notification button so each time I upload a new video, you'll be notified. And equally check some videos I have out there. Just go to NN Fabien Chemistry and I'm sure you'll find so many interesting videos. So before we continue, let's look at some very important definitions. So what is a solution? So a solution is a uniform mixture of a solute and a solvent. Now in the definition of a solution, we have two very important words here. We have solute and solvent. So what is a solute? A solute is the substance that is usually solid and it dissolves in the solvent, while the solvent is the substance that is usually liquid and it dissolves the solute. Let's take a look at this. Over here, I have salt. This is common salt, sodium chloride. And I have a glass of water. Now, what happens if I add this salt to the glass of water? What happens to it? The salt dissolves, right? So the salt that dissolves in this glass of water is known as the solute. So over here we have the solute. And what dissolves the salt? I'm sure you've said the glass of water. So this glass of water is what dissolves the salt and it is the solvent. Now, once the water dissolves the salt, it forms a uniform solution. It forms a homogeneous solution. So, a solution, once more, is a uniform mixture of a solute and a solvent. Now we know what a solute is and we know what a solvent is. Now let's look at the next important definition here. We are now talking about concentration of a solution. So the concentration of a solution is the amount of solute that is present in a given volume of solution. The volume usually considered is 1 cubic decimeter of solution, 1 dm cube. Now, concentration can be expressed in two ways. That is, as molar concentration and mass concentration. So, here we go. What is the molar concentration, also known as molarity? So, molar concentration is simply the number of moles of solute dissolved in 1 cubic decimeter of solution. And the symbol of molar concentration is uppercase M, and it is read as molar. What are the units of molar concentration? The units of molar concentration is or are mole per dm cube. Mole per dm cube. So concentration can also be expressed as mass concentration. And mass concentration is simply the mass of solute in grams that is contained in 1 cubic decimeter of solution. And the unit is in gram per dm cube. Now, how do we calculate the concentration of a solution in mole per dm cube and in gram per dm cube? For that, I have a triangle here. I want us to take a look at this triangle that summarizes it. Here we go. So over here, we can see a triangle that helps us to memorize the formula of calculating concentration. So if we cover this concentration, let's cover concentration like I've done here. What do we see? We can see moles divided by what? Divided by volume in dm cube. So concentration, the formula to calculate the molar concentration of a solution, concentration, that is molar concentration of course, is equal to moles represented by small n divided by volume. And take note, the volume is in dm cube, that is in cubic decimeter. That is the formula to calculate the molar concentration of a solution. Now, at times we could be given the concentration and we are required to calculate the number of moles or the volume. So how do we do it then? It is pretty simple. We can still look at it from here. If we want to calculate number of moles, we simply cover moles like I've done. What do we have? So moles will be equal to concentration multiplied by volume. Mole is equal to concentration multiplied by volume. And you could equally get it from here. If you transpose this formula, you can clearly see that moles will be equal to, that is number of moles. Number of moles is equal to concentration multiplied by volume. And take note, the volume is in dm cube. Similarly, we could be given concentration and number of moles, and we are asked to calculate volume. So it is pretty simple in that case. Volume will be equal to number of moles divided by concentration, which we could still get from this formula. So volume is equal to moles divided by concentration. And take note, this concentration is in mole per dm cube. Now, how do we calculate concentration? That is the mass concentration. Now, what you should note here is that to get concentration in gram per dm cube, concentration in gram per dm cube is simply equal to the concentration in mole per dm cube, that is mole per dm cube, multiplied by the molar mass of the compound. Take note, concentration in gram per dm cube is equal to the concentration in mole per dm cube multiplied by the molar mass of the compound. Now, it is important you also get to learn about these conversion units. Remember, we've said concentration is expressed in mole per dm cube. You should note that 1 dm cube is equal to 1000 cubic centimeters, and 1 dm cube is still equal to 1 liter. So concentration could also be expressed in mole per liters, because 1 dm cube is equal to 1 liter. Equally, 1 cm cube, that is 1 cubic centimeters, is equal to 1 milliliters. So now that you know all this, let's look at some examples. Okay, here we go. So we have some examples here. Example 1 says 0.38 grams of sodium nitrate is dissolved in water, and the solution made up to 500 cm cube. So take note of the volume here. We've got 500 cubic centimeters. What is the concentration of the solution in mole per dm cube? So here we're talking about the molar concentration of the solution. So how do we do this? It's pretty simple. Let's look at it. So we know that, let's look at it here. We know that concentration, that is molar concentration, is equal to number of moles divided by volume in dm cube. Take note, number of moles divided by volume, and the volume here is in dm cube. So the first thing we need to do to calculate the concentration of the sodium nitrate solution, we need the number of moles, and we also need to convert the volume into dm cube. So let's begin with the number of moles. So number of moles of sodium nitrate. We know that number of moles is equal to mass divided by the molar mass. Number of moles is equal to mass divided by molar mass. Very important. Do not forget. Number of moles is equal to mass divided by molar mass. So what is the mass we're given in the question? If we look at it, we've been given 0.38 grams. So here we have 0.38 grams. That's the mass. Now, what is the molar mass of sodium nitrate? Now, if you have difficulties finding the molar masses or the relative formula masses of compounds, make sure to check out my video on that. I've done a video explaining how to calculate the molar masses of compounds. But now let's just do it all together here again. So we have sodium nitrate. Good. Sodium has a relative atomic mass of 23, plus nitrogen has a relative atomic mass of 14. Oxygen has a relative atomic mass of 16, but we have 3 oxygen atoms. So we have 3 times 16. So that gives us the molar mass is 85 gram per mole. 85 gram per mole. So here we have the units. 85 gram per mole. Could also represent it as such. So now what do we have from here? We have 0.00447, which we could still represent in standard form as 4.47 times 10 raised to the power minus 3 mole. So this is the number of mole. But is that the final answer? Of course it isn't. We also need to convert the volume to dm cube. In the question, we're given 500 cubic centimeters. So that is the volume in cubic centimeters. So we need to convert it because the volume we should use here should be in dm cube. So to convert from cm cube to dm cube, we simply divide by 1000. So 500 cm cube divided by 1000 gives us 0.5, and the volume now is in dm cube. So that is the volume we're going to use. Now, what is the concentration? So concentration will be equal to the number of moles that we have here, 4.47 times 10 raised to the power minus 3 mole divided by 0.5 dm cube. So what does that give us? It gives us this is equal to 0.00894 mole per dm cube. If you want to represent it in standard form, it's going to be 8.94 times 10 raised to the power minus 3 mole per dm cube. So that is the concentration of the sodium nitrate solution that we've calculated. Let's look at the second example. What is the amount of sodium chloride in mole in 25.0 cubic centimeters of an aqueous solution of concentration 2.0 mole per dm cube? So here the compound is sodium chloride and the volume is 25.0 cubic centimeters, and the concentration, we have it here. So we have the volume and we have the concentration, and we have to calculate the number of moles. So how do we do it? Let's see. So we are looking at example 2. Now the first thing we should do is to convert the volume to dm cube. Remember, the volume here is 25.0. So volume is equal to, we have 25 divided by 1000. We are converting, that is 25.0. We are converting it to dm cube, and that gives us 0.025 dm cube. That is the volume. Now we know that number of moles is equal to concentration multiplied by volume, and the volume should be in dm cube. So let's see, we're given the concentration in the question. The concentration is 2.0 mole, so we have 2.0 mole per dm cube multiplied by the volume 0.025 dm cube. And what do we have? We have 0.05 mole. So that is the number of mole of sodium chloride in that volume of solution. Now let's look at the third example. The student wants to make a solution of 250 cubic centimeters sodium carbonate of concentration 2.0 mole per dm cube. What mass of sodium carbonate should he use? So we want to make a solution with a specific concentration. This is the concentration, 2.0 mole per dm cube in this volume, 250 cubic centimeters. So what mass of sodium carbonate should be used? Let's see what to do in this case. Okay, just like we know already, let's start by converting the volume to dm cube. The volume here is 250. So volume is equal to 250 divided by 1000. That gives us 0.25 cm cube. The concentration in the question we were given, it is 2 mole per dm cube. So our concentration is equal to 2.0 mole per dm cube. Remember, we are calculating mass. Now let's also get the molar mass or the relative formula mass of sodium carbonate. So we have MR of sodium carbonate if you calculate it, you're going to have 106. Like I said, if you have difficulties calculating relative formula masses, check out my video on that. So now that we have this already, let's see what we can do. Now we want to calculate mass, and we know that from number of moles we can obtain mass, because remember earlier on we saw that number of moles is equal to mass divided by molar mass. So if we have number of moles, we can simply multiply it by molar mass. So mass is equal to moles multiplied by molar mass. Good. Do we have molar mass? Sure we do. This is the molar mass we calculated, the molar mass of sodium carbonate. But do we have number of moles of sodium carbonate? We don't. So what we need to look for now is the number of moles of sodium carbonate. And for that we've been given, we know the volume, we know the concentration, and we know the volume as well. So let's see, moles, number of moles of sodium carbonate is equal to the concentration multiplied by the volume in dm cube. So what do we have here? We have 0.5 mole. Now that we have our mole, we simply need to come and replace it. So mass, therefore, the mass we need is equal to the number of moles, 0.5 mole multiplied by the molar mass, 106. And what does that give us? It gives us 53 grams. Now you may be asking yourself, how do we know the unit will be gram here? It is pretty simple. Here we have 0.5 mole. Molar mass is expressed in gram per mole. So we have 106 gram per mole. So mole cancels mole. We are left with gram. So it gives us 53 grams. Okay, now that we've gone through these examples, I want you to try these exercises. So go ahead, pause the video and try this. Okay, so try these exercises. We have 1, 2, and 3. That is the third exercise. All of them multiple choice. So pause the video and try this. Okay, I want to believe you've tried all the 3 exercises. Now let's look at it together. The first question says a tablet contains 0.080 gram of ascorbic acid. We've been given the molar mass of ascorbic acid. What is the concentration of ascorbic acid when one tablet is dissolved in 200 cm³ of water? So let's see. Here we want to look at concentration. And we know that concentration is equal to number of moles divided by volume in dm³. Do we have the number of moles? No, we don't. But we know how to calculate number of moles. Number of moles being equal to mass divided by molar mass. So 0.080 divided by the molar mass 176. So what does that give us in standard form? We have, so in standard form we have 4.54 times 10 raised to the power minus 4 mole. Good. Do we have the volume? Sure, we do. The volume in the question is 200 cm³. So volume 200 cm³ divided by 1000 to convert it to dm³. So we have 0.2 dm³. Okay, now that we have all those, let's see. Our concentration is now equal to number of moles 4.54 times 10 expo minus 4 divided by 0.2. And what does that give us? That gives us 2.27 times 10 raised to the power negative 3. So the correct option here is D. Did you get it right? Okay, let's move to the next. So 4.00 gram of solid sodium hydroxide is added to water to make a solution of concentration 0.200 mole per dm³. What is the volume of water to be used? So here we need to calculate volume, the volume of water to be used. Okay, so let's see. We know that concentration, number of moles, divided by volume in dm³. So from here, volume will be equal to number of moles divided by concentration. Okay, so let's see. Number of moles. So let's get the number of moles of sodium hydroxide. Number of moles of sodium hydroxide will be equal to, this is the mass of sodium hydroxide, 4.00. 4.00 divided by the molar mass of sodium hydroxide is 40. So this gives us 0.1 mole. Okay, now that we have that already, we simply come and we substitute. So the volume is now equal to the number of mole, 0.1, divided by the concentration that is it, 0.200 mole per dm³. So here we have mole and here we have mole per dm³. So finally, what do we obtain? So we have 0.5 dm³. Remember, mole cancels mole and we are left with dm³. And to move from dm³ to cm³, what we do is we multiply by 1000. So if you multiply 0.5 by 1000, you're going to have 500. So that gives us 500 cm cube. So the correct option is C, 500 cm cube. Okay, let's look at the third exercise. In a titration experiment, 20.0 cubic centimeters of dilute sulfuric acid was used to neutralize 25.0 cubic centimeters of 0.2 mole per dm cube sodium hydroxide. The equation for the reaction is, we've been given the equation. What is the concentration of the dilute sulfuric acid in gram per dm cube? Oh, so here we now need to calculate the mass concentration in gram per dm cube. Okay, let's look at the information we have. So in a titration experiment, 20.0 cubic centimeters of dilute sulfuric acid. So volume of sulfuric acid is 20.0 cubic centimeters, was used to neutralize 25.0 cubic centimeters. So this is volume of what? 0.2 mole per dm cube. This is concentration of sodium hydroxide. So here we have the volume of sodium hydroxide, 25.0 cubic centimeters, and we have the concentration of sodium hydroxide as well, that is 0.2 mole per dm cube. Okay, the equation for the reaction we've been given. Sodium hydroxide reacting with sulfuric acid to give us sodium sulfate plus water. Okay, what is the concentration in gram per dm cube? Now, we know that concentration, so here we want to calculate concentration of the dilute acid. So concentration in gram per, that is gram per dm cube, is equal to concentration in mole per dm cube multiplied by the molar mass. Okay, so what we need here is the concentration of the dilute sulfuric acid. So we need concentration of dilute sulfuric acid in mole per dm cube, and we need the molar mass of sulfuric acid. Already we know H2SO4, that is sulfuric acid. Hydrogen is 1 times 2, sulfur is 32, oxygen is 16 times 4. That will give you 98 gram per mole. 98 gram per mole, that is the molar mass of the sulfuric acid. So what we need now is the concentration of the sulfuric acid. But if we look at it, we've been given just the volume. And we know that concentration is number of moles divided by volume in dm cube. So let's see, concentration in mole per dm cube is equal to number of moles divided by volume in dm cube. But unfortunately for us, we have just the volume. We do not have number of moles. So what can we do to calculate the number of mole of sulfuric acid? That is what we want to look at now. So we're going to use the equation for the reaction. But before then, let's start by calculating the number of moles of sodium hydroxide. So let's get the number of moles of sodium hydroxide. We've been given the volume of sodium hydroxide, 25.0 cubic centimeters. But remember, we have to convert it to cubic decimeters. So number of moles, let's go, number of moles of sodium hydroxide is equal to 0.2, that is the concentration of the sodium hydroxide, multiplied by 0.025. This 0.025 is the 25 cubic centimeter that has been converted to dm cube. So this now gives us 0.005 mole. So we have that as the number of mole of sodium hydroxide. Now let us look at the equation of the reaction. So from this equation, we can clearly see that 1 mole of sulfuric acid reacts with 2 moles of sodium hydroxide. 1 mole of sulfuric acid reacts with 2 mole of sodium hydroxide. So the mole ratio is 1:2. So we're going to use that to help us. Anyway, let's put it this way. From equation, we can clearly see that 2 moles of sodium hydroxide reacts with 1 mole of sulfuric acid. So this number of mole of sodium hydroxide we calculated here, 0.005 mole of sulfuric acid of sodium hydroxide will react with, okay, we multiply 0.005 by 1 and we divide by 2. So that gives us 0.0025 mole of sulfuric acid. So now we have the number of moles of sulfuric acid. That is it. So we can conveniently calculate the concentration. So concentration of sulfuric acid now. So concentration of sulfuric acid is equal to the number of moles we got here, 0.0025 divided by 0.02. Remember, we have converted 20 divided by 1000. That is what has given us the 0.02 dm cube. So from here we now have 0.125 mole per dm cube. So this is the concentration of the sulfuric acid in mole per dm cube. So concentration now of sulfuric acid in gram per dm cube is equal to concentration in mole per dm cube 0.125 multiplied by the molar mass, that is 98. So what do we have? It is equal to 12.25 gram per dm cube. So let's check to get the answer. So the correct answer is A. Okay, so how many did you get right? So thank you so much for watching. Please, if you've not yet subscribed to my YouTube channel, make sure you subscribe and turn on the notification button so each time I upload a video, you will be the first to know. Thank you so much, and I hope this video was helpful. Remember to like, comment, and share the video. Bye-bye and have a great time.